All right, we're recording. Morning, everyone, and afternoon, depending on where you're coming from. Really glad you all could make time to be here today. I know it's busy season for many, or vacation season for others, so I'm glad that we're able to get a critical mass here today. I'm Allison Johnson. I'm an attorney with the Natural Resources Defense Council, and we're really lucky today to be joined by several farmers and beekeepers, as well as researchers who are looking at neonic-treated seed and ways that we can reduce use. The goal here today is really to hear directly from folks who have done their own research, whether it's in an academic setting or out in the fields, and reach their own conclusions about neonics and how they work or don't work for their operations. So we'll start by hearing from Roy and the work that he's done around neonics on his farm. Then we'll hear from Katja and Alejandro, who are doing side-by-side on-farm trials with neonic-treated seed. And then we'll hear from Cory, Kreft and Randall, Hidy about their experience as beekeepers and bee stewards and the impacts of neonics that they've seen. I want to just start out as we all come together to acknowledge what a hard year it's already been for Colorado agriculture. Started with a really warm and dry summer. I heard the bees were out really early this year, so we'll see what that means. And I know a lot of farms are dealing with drought impacts, as well as late frosts and crop loss, and now fires. So really thinking of you all who are struggling out there, and hope that we can, keep that in mind as the conversation goes forward today. I'm going to mostly keep my mouth shut and be here to facilitate, but also happy to answer questions. And we'll have about 30 minutes at the end for discussion and questions. So feel free to drop questions and comments in the chat as we go along, and then we'll open it up after we've heard from everyone. So with that, I will kick it over to Roy. Thanks for starting us off today.
Absolutely. Thanks for inviting me. I'm realizing my lighting isn't the best, but that's what happens when your office is in the basement. I'm just a brief introduction for those of you who don't know me. I farm with my wife and my parents south of Haxton, Colorado, which is up in the northeast corner of Colorado. We're a dryland farm. We're about 2,000 acres. And we run a really diverse range of crops. I do a lot of experimenting, so much so that a lot of people view us more into the research side of things versus just being a regular old farm. This year, I think we're at 13 or 14 different crops. I haven't done a final count after adding a couple of them due to failed crops due to drought. I also have some beehives. I actually work with Randall on those. My wife runs our gluten-free milling company. We also raise mushrooms, cordyceps mushrooms. So we do a lot of different things and see how nature is kind of interconnected and how all the different pieces work together. I initially started just looking at seed treatments in general and with the question of, do we really need them? And it's just one of those things that we're not organic, but we try to limit what we use for chemicals and herbicides and pesticides on our farm. And so started looking at it, do we even really need it? And did a lot of just research and study stuff, and kind of got to the point where I'd like to try without it. And so then I started looking for non-treated seed. And I found very quickly that it's very difficult to find. Luckily, we have a family connection with Stein Seeds in Iowa, and I was able to have a phone conversation with Myron Stein. And I was asking Myron, it's like, I'd really like untreated seed. And he goes, well, why? And it's like, well, the seed treatments generally are for cold, wet soils. And they usually, if you have a lot of disease issues or insect pressures, but in our arid environment, we really don't have those things. And, if they had a seed treatment for hot, dry soil, I would totally take that immediately. But everything they're doing is for stuff that we just don't have. And so the first year I asked him to send me half of my corn seed untreated. And I found out why it was so difficult is because the seed treater is literally bolted on the back of their seed cleaners. So it goes through the seed cleaner into the treater because everybody wants treated seed. And so they went out of their way to find a way to get me untreated seed. They actually had someone else clean it at a separate facility. And the first year I did half the field in untreated seed and half the field in treated seed. It was 2023, which the year started out okay, and then turned off terribly dry. We ended up with 6 inches of precipitation for the growing season. And in that, the corn, I mean, it came up and they came up fairly evenly between the two. What was interesting is usually at about V5, V6, we see leaf striping in our corn. And I talked to the agronomist and they're like, oh, it happens in all corn. It'll grow out of it. And what was that first year with the untreated seed, we didn't get any striping. And that was my first thing of, oh, we're actually affecting some sort of transport. And they said it was a zinc deficiency. So we're actually eliminating the micronutrients that help, or the microbiome that actually convert zinc in the soil into a viable zinc for the plants. And so it's like, oh, that's really interesting. The drought continued. The untreated seed, those plants, they held on. The following year, we never harvested the crop. They never got taller than knee high. It was a horrible crop. But the untreated seed, that area, I actually found volunteer corn plants the following year. So those plants that had no seed treatment, actually, even though they were knee high, they still put out tassels and set ears and actually made some viable seed. The treated side didn't do anything. It died like 2 weeks earlier than the untreated. So the following year, I told him I was going to do the same thing, but instead I said I was going to do a lot more extreme example. And I did 3 replicated trials of 4 acres each, and I did standard treated seed, and then I did numerous other seed treatments, and then just naked seed. And through the growing season, the naked seed actually wasn't necessarily the best. It was running behind some other microfungal treatments, but it was definitely better than the standard seed treatments that they ship on all their seed corn. And everything, we did ear counts and we were looking stuff at the beginning of late July, beginning of August. And it's like, man, the treated seed, that is going to be the worst yielder. And then it stopped raining and it didn't rain for the rest of the season. And when that happened, we went out and harvested all these plots. There were 18 plots total. We harvested them all and they all varied in yield by 1 bushel. So, I mean, insignificant in terms of difference. But in that, we took samples and then we ran protein tests and we looked at test weights and all other things. And what was interesting is the highest protein corn seed was the treated. Well, what we've learned about plants is if you want to produce protein in plants, you stress that plant. And that treated corn seed, those plants were stressed the entire season, which, yeah, it's nice. You have this higher protein, but looking at it, everything else across the board, test weight and grain quality and things like that, everything else was better. So that just kind of continued to lead me down that path of, I really don't want treated seed. We've learned that we can get it, but we have to order our seed in August. So we actually have to have projections of next year based upon what we raised this year, which doesn't work very well. But the one piece that I had with treated seed that to me kind of drives this point home is a couple years ago, we were going to raise sesame. Sesame is a drought-loving crop. They grow it down in Texas and Oklahoma. And we thought, it's, we do drought really well in Colorado. We're going to see what it'll do. And so I contacted a company to get seed.
Are you doing Breck?
No,
And when I did that, they're like, oh, well, we'll send you a 50-pound bag of treated seed. And it's like, well, how much is that? Well, it's $600. And it's like, okay, that's kind of expensive, but sesame's got a good return if it'll grow. And I said, well, do you have untreated seed? And they're like, well, yeah, we have untreated seed, but why do you want it? And I said, well, I'm not familiar with the seed treatments you use, and I'm, kind of sensitive about what goes on. I said, could you send me the label for what you are putting on the seed? And they sent me the label, and I went and I read the label, and right in the label, it was not very far into reading the label, it said right on it that this product is highly toxic to bees. And it's like, oh, well, that's not very good, because I have bees. I really don't want to kill my own bees, much less kill any other bees that are out there that are pollinating. And it's like, okay, well, that's a strike against it. And so then I started reading deeper into that label, and it said, this product has a half-life of 30 days. So what you apply to the seed gets absorbed into the plant, and the first, half of it disappears in 30 days. The next half will disappear in the next 30 days, where that leaves us 25%. The next half will leave in, the next 30 days. So we come out and we're about 12.5% of the product that is highly toxic to bees is still in the plant at that point. Sesame is a flowering crop. It's actually been labeled as a fairly decent pollen source. So it's like, oh, great. So I'm actually going to apply this to my seed, and I'm going to go out and I'm going to seed my sesame and not think anything of it. And those bees, when the sesame starts blooming, are going to come in there, because it's a whole bunch of beautiful white flowers, and they're going to go in there and they're going to collect that nectar. And if 12.5% of that chemical is in that plant, that means there's chemical in my nectar. And they're going to take that nectar and they're going to take it back to the hives. It's going to be in the hives. They're going to dry it, turn it into honey. It'll go into my winter stores. And then I'll have a beehive that looks fine going into fall. And next spring, it's going to be dead, because the honey that they stored has insecticide in it that is highly toxic to bees. And it originally came from the seed tree. And as a farmer, I had never thought of what is the half-life of that. And at that point, it's like, I absolutely do not want this seed treatment. So I called them back and I'm like, well, I want the untreated seed. And they said, why? And I said, well, have you read the label? I said, it's highly toxic to bees, and it's toxic to bees for the life of that sesame plant. And so they were able to get me untreated seed. It was only $400 a bag, so it was less. And the sesame experiment was a failure, but at least I know I didn't affect my bees with it. But it's one of those things that, they're out there putting the seed treatment on. Farmers are taking it because that's what's available and that's what's normal. And they're not taking the time to read the labels, because it's like, well, if the seed treatment the seed company put it on there, well, it must be important. I must need it. And, I had never read the labels on seed treatments before. And so by going in and like doing this, reading the label, realizing what's going on, it really highlighted to me how important it is that I'm able to find untreated seed without having to go through a bunch of hoops. And I've actually worked on finding the seed companies that will work with me. Most seed companies, you can order and we'll see if it'll happen. And so it's really frustrating And the big thing that we find is we actually don't have the problems in our soil, especially, we've been focusing on regenerative agriculture on our farm. We've been focusing on increasing our soil health. We have very healthy soils, so we actually don't even have a need for it. And there's a lot of farmers out there that don't realize the impact of that seed treatment and how it affects, it stunts the crop because, the zinc transport does show up back again. Those microbes do show back up and are able to do that. But with that, farmers don't have that knowledge, and they kind of have that expectation of, well, this is what I need. And then once they start finding out, my soils are healthy, I don't need this doesn't matter. Well, then the challenge is, how do I find this? And I think this, looking at this legislation where they actually have to consciously think about it. And if they need it, that's great. Then they still have it to use. I am not for banning the product, but I definitely want people to be aware and farmers to be educated and, having to show the need for it versus just throwing it out there and, impacting the environment without necessarily realizing the long-term impact that comes in on things.
Thank you so much, Roy. It's so impressive all the work that you've done just to be, careful and observant and the, impacts that you've identified. So thanks for walking us through that. Next, I'm going to turn it over to Katja and Alejandro, who are doing similar work to Roy, but across a bunch of different farms.
Thank you, Alison, for the invitation, and thank you, Roy, for sharing that experience. I am going to make a quick introduction. Let me see if I can share my slides. And please let me know if you can see the PowerPoint.
Looks good.
Is that coming through?
Yep, perfect.
So again, good afternoon. We're live from New York. I am Alejandro Calixto, and I serve as the lead of the Cornell Integrated Pest Management Program. And my colleague, Dr. Katja Poveda, is joining us as well. She's professor of entomology here at Cornell University. And I just want to do a very quick introduction about how we're supporting the growers because we're going to be transitioning away from the neonicotinoid treatments in 2029. And I just want to explain a little bit the legislation that was signed a few years ago and where we are and what Cornell University, as well as the Department of Ag and Markets and DEC is doing to help the growers prepare ahead of 2029. So I can spend probably half an hour just giving you a little background how this legislation came into place. There was a lot of work that started happening in 2018. Cornell University was involved in developing a very comprehensive report where the state asked us to look at the benefits and impacts of neonicotinoid insecticides in agriculture in New York State. What it was really interesting and compelling out of that report is that from all the uses in the state, we found that the highest risk to pollinators was coming from seed treatments, and that those seed treatments as well were not providing an economic benefit to the crop. So all that information helped, it was background information that helped drafting this legislation that is called the Birds and Bees Act. It was signed by the governor in December in 2023. I cannot remember exactly how many documents, how many iterations went through before it was signed. And the law, it reflects some negotiation between the industry and the state, and we feel it is a very comprehensive, very well balanced legislation. So the legislation has two components. It does impact seed treatments in field crops, but also impacts the use of neonicotinoid insecticides for turf and ornamental for non-agricultural production. That part of the legislation started in 2025, is in effect already. And the other component, the seed treatments, is the one that I'm going to introduce and explain a little briefly here. It won't go in effect until January 1st, 2029. So that's part of the environmental conservation law. You can Google and find the legislation if you're interested in reading more about the language. And here I'm just going to summarize what it says. It will prohibit the sale, use, or distribution of any corn, soybean, or wheat seeds coated with neonicotinoid insecticides. I always point out that the legislation includes corn. It does not separate corn for silage, for grain, or sweet corn. So it does impact a specialty crop, which is sweet corn. And then there is a wide range of active ingredients that are being used in seed treatments. And the three main active ingredients that are impacted in that legislation are clothianidin, imidacloprid, and thiamethoxam. So this is not a blanket ban, which means that the growers, they will be able to continue getting access to those seed treatments, but they have to submit, they have to apply for a waiver. And what is really interesting about this legislation, and as a lead of the IPM program in New York State, I have to be very proud of what we have accomplished, because this is probably one of the first legislations in the US that has a significant IPM component. And what the legislation requires is for the growers to determine the risk of having that pest in their crop so they can continue getting access to those seed treatments. And what I'm saying, that why I'm saying this is a novel legislation in terms of IPM, because it's really allowing us to go back to basic IPM principles. Those basic IPM principles are, you have to understand the risk of having that pest before selecting a tool to managing that pest, whether it's a chemical tool, biological control agent, cultural, or mechanical practices. This is very, very unique, and this is how IPM started almost 50 years ago. The growers also need to complete an IPM training. It's a very simple IPM training that we are developing, and just understanding basic IPM principles, know your pest, determine the risk of having that pest, selecting different tools. And then once you have that risk assessment tool and you complete that IPM training, you can apply for that waiver to the state. So if the state approves that waiver, it can be up to for 2 years. So after that, if you want to continue getting access, or the growers want to continue getting access to those seed treatments, they will have to go through all that process again. So again, it is a very unique piece of legislation. It's just, and maybe I'm too extreme when I use this example, but it's just like the medication that we buy over the counter. So are we taking 3 pills of Advil, of ibuprofen, thinking you're going to have a headache or a migraine in the afternoon? I think that's really not the purpose of those medications. It's going to put a lot of stress in your liver, and then you're going to create a problem that is unnecessary for your health. That is exactly the same thing that is happening in a situation. We're using a tool without knowing that we really need that tool, and we're putting a stress in the environment. So that report that I mentioned is what it showed. It's just the risk of using this tool is really outperforming the benefit of that tool. So we're going to try to make this as easy as possible for the growers. Cornell, if you read the legislation, Cornell IPM was instructed to facilitate this to the growers, develop the risk assessment tool for the growers to determine if they're going to have that risk of having that pest in their crop, complete the IPM training. So it's just a single sign-off location where they can complete that report, and then they can submit a request to the Department of Environmental Conservation for getting that waiver. We already have a training in place because, as I mentioned earlier, there is a portion of the legislation that impacts turf and ornamental for non-agricultural production. So any pesticide applicator wanting to use neonicotinoid insecticides for that purpose, they are obliged to use this training, complete that training, and this goes to DEC so they can continue getting access to those insecticides. This is going to be very similar for field crop growers in 2029. We have already a system in place. Just to give you some numbers, we have close to 500 people who have enrolled and taken that training. And that training has a lot of information about basic IPM principles, but also an understanding of what are neonicotinoid insecticides, as well as, Roy, as you pointed out, many people, when you grow the seeds, you don't really know exactly what comes in those seeds. So it's really increased the awareness and trying to help growers understand where you're putting on the ground. As part of the legislation, because all the way up from the governor and the commissioner of agriculture, they wanted to ensure that the growers were completely on board and they had the tools to transition from these insecticides. They provided some support to Cornell University to support the growers with that help. So it's very similar to what Roy is doing in Colorado, which is amazing. We have been recruiting growers since starting 2025, and we're conducting the largest on-farm research and demonstration project that has ever been done in Cornell University. So that on-farm project includes planting 2 1-acre plots, one with a conventional seed treatment and the other one with everything that comes on the seed except the neonicotinoid seed treatment. And it's like a natural experiment. We're just giving the seeds for free to the growers. We're compensating them to be part of this project. All we're doing is collecting the data from those plots. We have no control at all. No control at all on the practices on when they plant those seeds. We wanted to make this as realistic as possible because we're building that model to predict the risk of those pests that we found in field crops. And that's the data that Dr. Katja Poveda is going to share with you in a second. We're also providing weather stations like the one in the picture. We have the largest pest forecast system in the US that is called NUA. It's under Cornell IPM. That is a basic tool that uses environmental data and information, biological information from the pest, so you can predict when that pest is going to be a problem. So many of the growers are being part of this project. They are also receiving a weather station as part of the project. Just very, very quickly, we have close to 80 farms that we have recruited in the past year and a half. We have field corn, soybean, sweet corn, and snap bean. And again, we have 2 1-acre plots. And there are some locations that we're actually adding a third treatment. And I'm just going to let Dr. Katja Poveda to talk more about that. So again, this is probably the largest on-farm research and demonstration project that we have in Cornell University. But also it's for the growers to grow those crops by themselves and see that they can grow without using that insecticide seed treatment. We have in 2022, before the legislation was signed, we assembled a group of experts. This is not a two people project, Dr. Katja Poveda, myself. There's almost 40 people involved in this project, people from Cornell University, the industry, the state as well. But also, very important, we have a group of extension specialists that are on the ground. They're the ones working with the farmers, recruiting the farmers, collecting the data, and of course, Dr. Katja's Poveda lab, who has been the heavy lifting, doing the field work in these locations. So with that, I'm just going to pass the microphone to Dr. Poveda, and I guess I'll be happy to answer any questions at the end. Thank you.
Thank you, Alejandro. I just sent a request to Alison to share. Oh, thank you. Second. Okay. I hope you're all seeing what I'm seeing. Can I get a thumbs up from somebody?
Looks great.
Okay, perfect. Thank you. So thank you so much, Alison, for the invitation, Alejandro for the introduction. I am sorry for this weird angle, but of course my camera stopped working today, so this is what we have to work with today. So what I'm going to do today is to talk about what we have learned in the last few years about early season pest damage across New York in light of the neonicotinoid ban. And I'm going to start with the report that actually motivated the Birds and Bees Protection Act. So when a colleague in Cornell started all this work, he put together all the information that they had on what does the removal of this neonicotinoid seed treatment do on yield. And so they looked at the information that was available and they found 330 trials where somebody else has done an experiment comparing neonicotinoid treated seeds and fungicide treated seeds. And then they found that in 83% of the cases, the yield was exactly the same for those two treatments. Let me just see. So interestingly, in 13% of the cases, actually the fungicide-treated seeds produced a higher yield than the neonicotinoid-treated seeds, and just 4% of the neonicotinoid-treated seed had a higher yield than the fungicide-treated seed. But we know obviously that this is not New York. Most of these studies were done in Europe or in Canada. And so we wanted to see what is the actual risk for New York State growers if we remove neonicotinoid seed treatments. And we wanted to look at this in terms of early season pest damage, stand counts, and yield. So the other part of New York State is that New York State is a dairy state. It's the most important agricultural commodity. And so for that reason, manure is one of the most used local managements for fertilizing. So we wanted to know how local management practices, such as manure, but also cover crops that are supporting soil health, can affect the risk of removing neonicotinoid seed treatments. So are these local management practices increasing the risk if we don't have neonicotinoids? As Alejandro mentioned, this would not have been possible without the involvement of so many people, the funding from the state, the collaboration with IPM, with the Cornell Cooperative Extension, but also the buy-in of more than 70 growers in New York State that have been working for us for a few years now, for us to be able to do these experiments and show what's actually happening on the farm. And so to give you an idea of what our experiments look like, so last year we started with 56 farms, and this year we already have 72 farmers that actually agreed to work with us. All the work is done on their farm. Most of the farms are planting field corn or soybean, and there are rotations between those two. And we have a few farms with sweet corn and snap bean. So on each of these farms, the growers agreed to plant 1 acre of fungicide only over the year. So the same treatment will be planted each year, even if there's rotation between soybean and field corn. That acre remains fungicide only, and 1 acre with fungicides and neonicotinoids. And each grower decides on the planting date and any other management practices that are going to happen on that field. The only thing we do is we provide the seed and sample. And so this is a timeline of how this works. So at planting, the grower will get their seed. 1 acre is planted with and 1 acre without neonicotinoids. 7 to 9 days later, all our collaborators dig up the seeds and they send it to us to the lab to dissect and look for seed corn maggot, larvae, and pupae. So seed corn maggot is our main pest in the region here. And I'm happy to talk about the seed corn maggot if somebody's interested in like their biology. At emergence and again at V3, V4, we do stand counts. And then at harvest, we measure yields. And when I say we, like, yeah, it's a ton of people involved. So let me show you the first data. So this is pest abundance for 2025. We will see the average seed corn maggot per seed. And here we have field corn. And this N equals 33 means that there are 33 farms that had planted field corn in 2025 and 16 farms that had planted soybean. And I'm going to show you the comparison between the fungicide treatment and the neonicotinoid treatment. So for field corn, we did not find any differences between the fungicide treatment and the neonicotinoid treatment. And if we look at the amounts of seed corn maggot, what we're basically finding is that for 100 corn seeds, we're finding 3.2 maggots. So the abundance of maggots is really low on these seeds. If we now look at the soybeans, we see that the fungicide treatment has actually a higher proportion of seed corn maggot in comparison to the neonicotinoid treatment. So we're finding around 6 seed corn maggots per 100 seed for the fungicide treatment and 2.7 seed corn maggots per 100 seed for the neonicotinoid treatment. These were data from 2025. We have our preliminary data for 2026, where actually the abundances are even lower than last year. And there's no significant difference for field corn or for soybean, and we're finding 6 seed corn maggots per 1,000 seeds or 9 seed corn maggots per 1,000 seeds. So the abundances are extremely low at this moment. So does this pest abundance that we found in soybean here translate in any effects on stand counts or yield? And it actually does not. So these are stand counts, and there's no difference between the fungicide and neonicotinoid treated seeds for field corn or for soybean. If we look at yields, so in terms of silage yield, there's no difference between the fungicide treatment and the neonicotinoid treatment. For grain yield, again, there is no difference between those two treatments, and soybean yield, there's no difference between the fungicide and neonicotinoid treated seeds. So our preliminary results suggest that seed treatments can reduce the abundance of early season seed corn maggot in soybean, but this just happened in 2025. We see that seed corn maggot pressure is extremely low, and neonicotinoid seed treatments does not provide a benefit in terms of stand counts or yield. So our preliminary recommendation is that there seems to be no cost in removing neonicotinoid seed treatments in terms of stand loss, biomass, and yield for field crops. However, it's very important that we got damage reports from growers outside of this experiment. And this is important because, yes, we are covering 70 farms, but we're not covering all the farms. So in 2025 and 2026, we were collecting reports from growers, and we found 5 cases in the state in 2025 and 2 in 2026, both for field corn and soybean. These cases were planted on the early side, so between April and mid-May. And 3 out of the 5 cases from last year, this required replanting. What's interesting is that all of these cases, the seed treatment, they had neonicotinoid seed treatment. So in 4 cases, they used Cruiser Max. 2 used a product that was not specified, but we know they used neonicotinoids. And in 1 case, they actually used neonicotinoids and the diamide. And so from the data we have right now, this suggests that the wet, cool conditions can drive the seed corn maggot damage, and that right now this is regardless of seed treatment. So part of the question that came out of this report is that is early planting increasing the risk of seed corn maggot damage? And there is some evidence like from the past that it is one of the highest risks is planting very early. So we looked back at our experiments that we did in 2023 and 2024 when we can collect seed at different times. And the way we did that is using this wire mesh. So here on the right, you see, basically it's a wire mesh. You fold it in the middle and you bait it with seeds. So you can bait it with lima bean or corn seeds or soybean seeds. And then the advantage of this is that you can take the wire mesh out, like put it mid-April in the ground, take it out, and then replace it with a new wire mesh 2 weeks later and 2 weeks later, so we can simulate different planting dates. And when we do that with a late April planting date, early May and mid-May, and there's always 2 weeks in between. So this late April is April 18 in 2023. We can see how that's affecting the percentage of corn seeds damaged by the seed core maggot. And what we see is that, yes, early in the season, we're finding more damage than later in the seasons if we are like stay in the same fields. And we repeated this experiment. So we had also data from 2024, and we found something very similar, that if we plant, like in that case, when we planted in early May, we found 1 damaged seed and 4 seed core maggot, while if we plant in late May, there is no damaged seed and almost no seed core maggot, so per 10 seeds. So to the question, is early planting increasing the risk of seed core maggot damage? It seems to be that way. And so now we're exploring how day temperature and rainfall are affecting the risk of seed core maggot. So I promised you that I also wanted to look at local management practices. We think this is very important, mostly for manure use, but also for cover crop if growers are care about the soil health, which is so important. So in this case, so one of the biggest questions we've gotten is should we be concerned about using manure? And the simple answer is no. We have done several experiments over the year. This is just one where we had 3 sites, 10 blocks. We counted more than 1,000 corn seeds where we looked at individual seeds. And basically between no manure, this is just regular fertilizer, versus an experiment where we applied manure on top of it, we don't see any difference between the no manure, the manure applied, and the amount of seed core maggot of corn damage, again, is extremely low. So we're finding 2.5%, which is 1 out of 40 seeds is damaged. But this experiment where we're looking at manure is not just about manure. We are actually combining it with an experiment for seed treatment. So we have one part of the field is not manure, the other part of the field has manure, but then the rows have fungicide treatments, diamide treatments, untreated seeds, or neonicotinoid-treated seeds. And what we're finding from these experiments are the following data. So just to walk you through the graph, this first 2 columns are untreated seed. The left column is also no manure, and the right column with manure. Then we have the fungicide-treated seeds without manure, with manure, neonicotinoid-treated seeds without and with manure, and diamide-treated seeds without and with manure. And we can see that in this case, in this experiment, neonicotinoid and diamide treatments did reduce the proportion of seed damaged in comparison to completely untreated or fungicide-treated seeds. If we then look at stand count, we don't see any differences anymore. So untreated fungicide, neonicotinoid, and diamide seeds have basically the same stand counts, but also the use of manure does not change the stand count in this case. And if we take all the experiment to yield, again, we don't see a difference between the different seed treatments and the use of manure. So in addition of the use of manure, cover crop, as I said, is another very important local management. And in this case, we had actually growers work with us, growers that are using cover crops and care about their soil health. And they agreed to have part of their field with a cover crop and part without cover crop. And then the rows were planted again with different seed treatments, fungicides and neonicotinoids, and fungicides and neonicotinoids and diamides. And so this was, again, an experiment done on growers' farms. And again, we're finding that there's no difference. So this is the no cover crop treatment on the left, the cover crop on the right for a fungicide treatment, neonicotinoid treatment, and neonicotinoids and diamides. And we don't find an effect of cover crops or seed treatment. And we look at yield again. we're not finding any difference between cover crop and non-cover crop, but also not between the different seed treatments. And we're definitely not seeing a reduction when we're just using fungicides. So from these two experiments, we can say first that the abundance of seed corn maggot larvae and pupae is very low, that neither cover crops nor manure application appear to increase seed corn maggot damage in corn, and that diamides and neonicotinoids sometimes reduce seed corn maggot abundance, but they provide no advantage in terms of stand counts or yields. So our preliminary recommendation in this case is that it is safe to continue using manure and cover crops in field crops. And I want to thank you for your attention, the giant team of people and growers that has made this possible to get this data, and I'm happy to answer questions probably at the end. Thank you.
Thank you so much, Dr. Calixto and Dr. Poveda. This research is so informative, and seeing the side-by-side trials on real working farms, I think makes a huge difference in how confident farmers can feel about relying on what you have identified as the impacts of neonic-treated seed. And we're also really excited in Colorado that we'll have the opportunity to build on your research as far as predictive technology and tools that farmers have at their disposal to make these decisions about whether they may need a neonic-treated seed or not. With that, I think I saw Cory on. We'll hand it over to Cory and then Randall to hear from a beekeeper point of view how neonics are showing up in your world. Cory, are you there? Where did you go? Move on my screen. Cory, if you're able to talk now, that's great. Otherwise, we can go to Randall and loop back to you. I know Cory's out working with bees as we speak here. Randall, let's kick it over to you and then we'll loop back to Cory.
All right, thank you, Allison. My name is Randall Hidy. Beekeeper here in the Denver metro area. This is my 7th year as a beekeeper, so not too terribly long as far as beekeeping goes, but long enough to become pretty passionate about it. It's been pretty life-changing stuff for me. The last few years, I've managed about 100 of my own personal colonies. I have several different locations along the Front Range where I keep bees. I also do beekeeping services, help other beekeepers with their hives. If I can find time, there's a beekeeping store in the Thornton area that I'll go help build boxes and frames and paint boxes, help build equipment. Helped build a decent amount of the beekeeping equipment for the hobbyist beekeepers here in the Denver metro area. Also breed and sell bees as well as selling honey. I guess to start out, I'll say I'm not exactly sure why my name has been coming up lately to talk about this neonic stuff, but I appreciate you all listening. A few months ago, I had a reporter from Colorado Public Radio, by the name of Ray Solomon, contact me, hoping to interview me about this neonic stuff, and so she ended up meeting me at one of my apiaries near the Denver Tech Center and asked me a bunch of questions and kind of showed her in some beehives and taught her some stuff about bees. Basically, I think she was expecting more of me to describe some kind of catastrophic event. Sometimes your bees get into spray pesticides. It's pretty easy to kind of see. If you walk up to your colony and there's 50, 60,000 dead or dying bees, sitting on the front porch, it's pretty easy to figure out the cause. Whereas with the neonics, it's not as necessarily easily to tell kind of what's going on. Because the neonics are water soluble, it gets into the plant on a cellular level, grows inside the leaves, goes inside the pollen, the nectar, the fruit, the vegetables. And like Roy was saying, that toxicity level, it depends on the half-life of that actual chemical and the maturity of the plant when, it's actually that pollen or nectar is actually being collected. And so, although it might not be at a lethal level, it's still in that pollen or nectar. It's still being brought back to the hive. It's, being absorbed into the beeswax. It's being absorbed into the wood of the woodenware, the actual equipment that you're, using to house your bees. And so, that nectar and that pollen ends up getting fed to the brood, the babies, those eggs and larvae, if they're getting fed, pollen and nectar that has those neonicotinoids in it, it affects their developmental stages. They can have growth abnormalities or, even, just cause them just, grow smaller, for instance. Which if you think, as a bees, when they collect nectar, they basically have two stomachs. And so to make honey, they'll go collect water and nectar, bring it back to the hive, put it in the cells. But if you can imagine the bee is smaller, it's not going to be able to collect as much water. It's not going to be able to collect as much nectar. And so it's going to have to make more trips each time to try to get the same amount. And it's going to be just less efficient, use more energy, it just really affect its lifespan. Another thing to keep in mind is that bees can become sick just from stress alone. Chronic stress directly weakens their immune system, lowers their natural ability to fight, viruses and bacteria. And neonics definitely put stress on colonies. Although the neonic exposure, might not just outright kill the colony, but it really just affects the overall health of the colony, and it can cause them to become sick. And so, if you, depending on what kind of sickness they can get, if you're not treating that, they could cause the colony to collapse. And so without, actually taking samples and sending it into a lab and paying for laboratory testing, the average beekeeper might not even realize that it's the neonic exposure that's causing their bees to become sick and die. Personally, I've started giving my bees a microbial probiotic supplement. It's supposed to help detoxify against the adverse effects of pesticides. The way I look at it, it's just another tool, my toolkit to, make my bees healthier, keep them healthier. This past winter, it's almost like we didn't even have a winter. But 2 winters ago was the worst winter on records the last few years. In 2024, 2025 winter, a lot of beekeepers reporting losses of like 60 to 80%. Some were reporting losses of 100%. And so, there's just a lot going against the bees, and the bees, honeybees have been getting a lot of attention lately. But it's not just the bees, it's all of our pollinators that are hurting. Because these neonics are water soluble, they get into the soil, they get into the watershed, the water runoff, they get into our streams and rivers. Neonics are showing up in milkweed, which is, a main source of food for some of our caterpillars and butterflies. Caterpillars eat the leaves, ingest these toxic chemicals. Sometimes birds will eat the caterpillars, or they'll fall in the stream, the fish will eat them. Now these chemicals are just moving their way up and through the entire food chain. And I don't think people realize, that most consumers, I don't think they realize that, this is in our food, it's in us. I didn't even realize it until a few years ago. I was, having a conversation with Roy, and I didn't realize that it was on, this treated seed was a thing, and that it could grow inside the plants, and it was on the cellular level. But I'm a farmer too, I understand this is a complicated issue. I understand that, there's invasive pests and they can decimate crops. My bugs get bugs, bees can get parasites. And so sometimes you have to treat your bees. But you got to do that carefully, right? You got to be paying attention, because you want to kill the parasites, but you don't want to hurt your bees. Because your bees are important, right? Like I said, it's 1 out of every 3 bites of food that a honeybee is responsible for. And so, in my personal opinion, I think that, treating seed as just a standard is kind of like saying, let's just kill all the bugs, because there's a chance that we might get one. There's this chance that we might have invasive pests, so let's just kill them all, so to make sure we don't have any of them. And some of those bugs are really important, actually. You know, we need some of those bugs, some of those, you know, microorganisms in the soil and in the rivers, you know, the bugs flying in the air. We need those bugs. Um, and so it's not just me, you know, me and my bees that's being affected. You know, as members of the food chain, it's every single one of us that's being affected, you know, by these chemicals. And so, like I was telling, you know, Chad and Tyler with the Rocky Mountain Farmers Union, we were having a conversation a couple of weeks ago. You know, I'm remaining hopeful that we can find some solution to these issues because this is important stuff. Um, and I think with that, I'll turn it back over to Allison. Thank you very much.
Thanks so much, Randall. Yeah, you really hit it on the head just as you're out observing effects. It's so hard to know what is causing what. I hear from beekeepers a lot, varroa mites or neonics, and there's way less funding and support for doing the research on those combined effects than we would like to see. But I think a lot of folks are piecing the story together, and you just laid it out really beautifully. So thank you. Cory, are you there now?
Yeah, can you hear me now?
Sounds great. Go ahead. Thanks.
Yeah, no problem. Thank you guys for having me. Mr. Randall, you said a whole mouthful. You did a great job. That covers everything in the bee industry. I started in 1996 in the bee industry. I was 15 years old, just a hired punk, and now own the business. We bought that in 2008. But even before that, so we run around 2,500 hives on the average, and uh, we started seeing a lot of this neonicotinoid coming around 2004, 2005. Jeff Pettis was the head entomologist for the USDA, and he was trying to get a lot of things done as to regulating the neonicotinoids a little bit better. And it fell on deaf ears. And so, honestly, for 20, 21 years now, we've all been in the commercial industry. We've been battling the neonicotinoid problem. Uh, Randall talked about using some probiotics that we treat the bees with that are prebiotics and probiotics for their guts. So the science has gone into coming up with ways that allow the bees to try to digest these pesticides, which is not a bad thing. And we do. I mean, we throw the kitchen sink at them. We medicate with anything and everything. A lot of essential oils, prebiotics, probiotics. We obviously have to treat for the mites. That's a constant battle. More or less like fleas on a dog. We have to keep pretty much a flea collar on the bees to keep the mites off. And Randall was right. The way we have to take care of a pesticide or a pest on an insect, which is not easy. But besides that, the neonicotinoids have devastated the commercial bee industry. A couple years ago was, like Randall said, was the worst ever at 73 to 75% national loss. And the worst thing of that whole situation is that most beekeepers, commercial beekeepers, are well over 60 years old. The average is getting closer to 70-year-old now. I'm 45, so I'm one of the younger guys in the commercial industry. But there's no new guys coming into the commercial industry. They've all There's no enticement. Nobody wants to try to keep bees alive anymore because it's almost impossible. There's so many battles. We have too many wars going on trying to keep the bees alive. There's a lot of weak-hearted people that just throw their hands in the air and say, "Forget it." I'm tenacious and I don't give up, but it's getting close. It's getting tough. Financially, you can't make a living doing it anymore. Honestly, in 2020, I had to start a butcher shop just to try to make ends meet to to support my beekeeping habit. And as a commercial beekeeper, I still keep going at it. Last spring, a year and a few months ago, we started the spring off with 2,900 hives, and we lost probably 50% of those through the fall because of neonics. Guaranteed it's neonics because there's no bees left in the colony. They get confused and never make it back to the hive. You end up with a small cluster the size of your fist with a queen in the middle of it, and it's because they've been poisoned and they can't, their GPS is not working to guide them back home again. And got them out to California, and we were down to 400 hives. Went from 2,900 down to 400 hives. And this didn't happen 10, 15 years ago. We would have 10 or 15% loss, not 85% loss. It's been devastating for many years. It really started bad about 10 years ago, and it got worse every year, and it hasn't gotten better since. So we fortunately have enough friends that helped us dig out of the trenches, and we come back to Colorado this spring with 2,400 hives. And we just keep battling back. And I don't know how many times a guy's pocketbook can afford to keep digging into that. So the pesticide, the neonics need to be regulated. Something needs to be done with it. It's hurting the immune systems of the colonies themselves and allowing other viruses to set in that we never even heard of these viruses 15 years ago. Now we've got a dozen different viruses that come into the hive, and it's nothing that we can actually medicate for. You can try everything under the sun, but once you realize you have it and pay for testing for it and get the results back, the colony's dead. So it's kind of a moot point. There's no reason to really push that hard into it, besides keeping your hives at the highest strength and keeping them as strong as you possibly can, constantly feeding, constantly treating, giving essential oils and all kinds of other uh, gentle medications without using any antibiotics or anything like that. More holistic stuff, but it's just a constant battle, and something needs to be done to correct this thing. The European countries figured this out in around 2005, and they got rid of all that stuff, and their bees have flourished and done well. And the United States has to do something to turn this around. That's about what I have to say. If you guys have any questions.
Thank you so much, Cory. I don't think many folks appreciate the impact of these hive loss numbers that we're seeing year after year. So I appreciate you putting some numbers on it, and we hope we find a solution for you soon. With
Let's
that,
keep battling.
Keep battling, exactly. And all of you, so again, the resilience to keep up in ag and keep finding solutions under so many stressors. I'm just constantly impressed by the resilience of our agricultural communities and the folks who are leading the charge on keeping ag alive. So thank you all. With that, we have some time for questions. You're free to type something and drop it in the chat or raise your hand or just come off mute. Really, really interesting presentations, and I'm sure there are some questions out there. I can warm us up with one. Oh, there we go. Ending in 441.
Hi, this is Drew.
Drew.
Sorry, I haven't been on these meetings for a minute, but I just wanted to review something. When we were not lobbying, but when we were going through all the legislation and meeting with all the senators and had the webinar on neonics and stuff like that, my biggest concern for the whole thing is I run an association in Southern Colorado, and I'm also on the state board. I could not believe how many beekeepers in the state of Colorado that had absolutely no idea what this was. So moving forward, I've been really super busy, but moving forward, we need to pull in the State Beekeeping Association. There's a couple board members on there that still think it's lobbying. They don't want anything to do with it, but that's where I would like to help, getting these hobbyists, not the commercial, not the sideliners, because they all know what it is. I think we need to focus on the hobbyist. I think that they can help us fight this a little bit, because there was so many, even in my association of 181 members, that did not even know what that was. They were like, what is that? How do we do this? By then it was too late, but moving forward, I can maybe help pull some of these people in to get knowledgeable, number one, and help us get the word out, because so many people in Colorado don't know what this is. So, Randall, I just had one question. What labs are you using for testing? Because there are not very many open anymore.
Well, I've never sent mine in for laboratory testing. I was just saying, like in general, if a beekeeper, if they wanted to know, they would have to literally take a sample, pay for it to be sent in, pay for the testing.
Right.
So yeah, I'm not too familiar with which labs, and I know I think one of the laboratory testing places just got shut down, didn't it?
Yeah. So that's what I'm saying. We need to work on that, some labs, because they've all been shut down. And it takes so long to get the results back. Just like Cory said, you get the results back. They know what it is, but it's too late. So maybe work on setting a lab up in Colorado with Sam Ramsey or at Boulder, stuff like that. We need to work on stuff like that within the state. We can't be sending our samples to Florida and wait 6 months for results. It's not working. And we didn't have a leg to stand on when this bill went through. And because people were not knowledgeable. We just need to educate people more. That's my input on the whole thing. I'm willing to stay on board, help with this, but they have to know about it. We got to get the word out somehow.
Hey, Allison, didn't on the call on Thursday, were there some people from the Boulder County Beekeepers Club that said that they were going to start taking samples to send them?
I think so.
Okay.
Yeah. Oh, yeah, I've heard the same thing, that just access to testing is tough, knowing what to test for. But it would really help to have more numbers. There is some research happening, or that has happened at CSU, with really low dose exposures for wild bumblebees, where you can see pretty dramatic results from that low level exposure. But really take your point, Drew, that neonics are the most widely used insecticides in the US and globally, and they're not something that a lot of folks are familiar with. So getting the word out is really important. Dr. Calixto, in your slides, I think you had a really great result from the training, where the pre and post test results went up pretty dramatically. So just half an hour, and folks really increased their understanding. I don't know if you have any other points you wanted to make around education and outreach.
Yeah, listen, that's a good question. So that's an interesting cohort of people, because those are pesticide applicators, so they probably have better understanding and knowledge of neonicotinoid insecticides. I think that among growers, that's going to be more dramatic. I think there is going to be a clearly difference before and after. We're doing a lot of work right now. In fact, we have a field day tomorrow, where we're just engaging with the growers, explaining what we're doing, but also explaining the risk of neonicotinoid insecticides, and helping them to understand just what comes on those seeds, because it's not only the insecticides, there's many other things that are being put on the seeds that they're not really aware of when they're planting. So I think that's the IPM training was developed a year and a half ago. Our colleague, Dr. Scott McCord, and one of his students helped us putting that together, because they were part of that report that Dr. Poveda mentioned. And it needs to be as well approved by the state agency before we post the new one for the growers. But I think that the main point is understanding of the risk and the benefits of neonicotinoid insecticides, the IPM principles, and for the growers to really like we do with any other pesticide, you have to read the label. But seed treatments is a really great area because the seed is not a treatment, it's being treated with pesticides. So if I buy seeds, I'm not required to read the label. So it is beyond neonicotinoid insecticide. This is a much bigger problem. And I think that we have to do a better job as a land grant system and the other systems across the state, working with the growers so they can understand completely what they're putting on the ground and the risk benefits of what you're putting on the ground. So you're talking about soil health, is beyond pollinators. So I think that's kind of the role and part of the purpose of developing that IPM training and get it improved before 2029.
Thank you. And Roy, I know you've had some neighbors who are interested in what you're doing. Do you have anything to add around getting the word out to farmers?
It's really challenging because it's been ingrained for so long that your seed comes and it's a different color. It's weird to plant corn seed that actually looks like corn seed. That's not some very bright color for warning you that it's been treated. And so there's a lot of resistance because it's ingrained that they need it. The one thing that I learned, I got to know someone who actually was a breeder for Pioneer, and the only time they treat corn seed is when it goes to the farmers. When they're breeding it and they're hauling it down to Brazil and doing things like that, they don't put any seed treatment on it. And so it's like, well, why are you treating it when it goes to the farmers? And I have the question of, what is the effect on soil health? Has anybody actually looked at the microbial communities and how have they changed due to different seed treatments? Not just neonic, but all of the different, because I've actually seen effects on soil organic carbon. We work with a company that provides satellite data to track soil organic carbon, and you can see fungicide applications on the crop affect that soil health. But what about, the seed, because it's directly in there?
Yeah, really good point. I just dropped a link to a blog that my colleague who's a soil scientist wrote about neonics and soil health. Dr. Poveda, did you have something to add there?
Yeah, I just wanted to say that that's an excellent question, Roy, and that's one of the things we are looking into right now, actually, like testing microbial, but just so for fungicides, neonicotinoids and diamides, but starting to look at microbial communities. But yeah, soil health is this black box, and there's so many things happening that I completely agree. We need to look more and learn more of what's happening there. Yeah.
Well, and that's what kind of keyed me off that first year that we raised untreated seed, and it didn't go through that normal period of leaf striping due to zinc deficiency.
Mm-hmm.
And as soon as I saw that immediately it's like, oh, we're actually changing the biome of the soil.
Yeah.
And of course, 20 years ago, farmers didn't even talk about soil health because it was, the soil is a growing medium. It's not alive. And, we've been doing these things for generations, and, what have we screwed up, kind of thing.
Yeah, that observation is fascinating, right? I'm curious to dig in more. Do we have any more questions? Feel free to raise your hand or come off mute or drop something in the chat and I can read it out to the group. All right, question from Laura Poss for Roy and Emily. What is the reaction of your neighbors? In my part of Colorado, the people that I've spoken to are going to oppose this legislation, and I think that our state representatives and senators will too. What words do you use when talking to your neighbors and community members to have them understand the detrimental impacts of neonicotinoids?
I usually just talk about, do we actually need it? And nobody can really answer that. And that's what I talk about when, looking at this legislation. This legislation isn't for banning it. It's just identifying the need. So it's, looking at more of an educational, position versus, the harsher side of things. And I think that was actually a thing that Allison and I talked about. Was I'm not against, regulating it. I think it's actually a really good idea. I just don't want to come out and banning it, because sometimes there is a need that cannot be addressed other ways. And so I don't want to eliminate it. I just want to be able to have farmers understand what they're actually doing and making a choice that's in a long term, better for the health of their soils.
Thank you.
Laura, thank you. One possible follow-on for Cornell team, one of the concerns I think around identifying that need and the challenges that farmers might face in taking that hard look is how you actually do it, what factors you're looking for, and how many people it might take. Can you talk a little bit about the tools that you've been developing and how farmers might play a role in doing some of their own verification potentially?
Katja, did you want to take on that, and then I can just add more?
Why don't you start? Yes. Yeah.
So, well, we're doing several things. We're looking, one, because growers that have to comply with the legislation, is developing a risk assessment tool. And the risk assessment tool, and we have a system where we can forecast almost 40 different pests. Those systems use weather data, temperature, rainfall, soil moisture, and information from the pest. So like insects, they need certain temperatures to complete their life cycle. So you can very accurately predict when that pest, when they're going to start, the eggs are going to start hatching, when they're going to become larvae, when they're going to be pupae or adult. And then you can kind of make your IPM decisions of what to use around those models. In this particular case, this is a different beast. We're working with a system that is spend most of the time underground. So, and Dr. Poveda has been working for almost 4 years with seed corn maggot. They go out and they get a lot of adults on sticky traps, and the numbers, they don't relate with the activity under the ground. So we don't see, you can see sticky traps covered with adults, but you don't see the damage, or you don't see, we cannot develop a threshold based on that. So what we're doing right now is looking at additional environmental factors that are driving the damage. When we find the damage, which that's been another complicated problem for us, a very interesting research problem, but because the incidence of the damage is so low, Dr. Poveda and her lab haven't been able yet to develop a model that predicts the risk of that pest. And we need a model that can, like Roy, you said, you're placing orders in August, September. It's kind of similar here in New York. You got to start planning 6 months in advance. So we need a model or some sort of tool that can help predict that far away in the system. So right now we're looking basically at windows of planting, like April, May, temperatures that are below 40, 45 degrees when it's rainy. That's where we've seen the highest incidence of that pest and damage in the crop. So that's one thing that we're working on. The other thing we're doing is looking at alternatives. So we're looking at non-chemical and chemical alternatives. So we're looking at chemicals that are already registered as well. So we're looking at diamides, which everybody knows is already probably been put in some seeds on corn and soybean in the US. We're looking at relatively all pesticide that is called spinosad is registered as an organic product. It's an old generation pesticide, but because it's not systemic, you're really reducing the risk of movement of target. That's been the biggest issue with systemic insecticides, is the off-target movement in the water and the air. So these chemicals, although a little bit old, they are proven to be safer in relation to non-target species. And then we're looking at some novel chemicals and non-chemical tools. So we have a professor in the Department of Entomology, Dr. Jennifer Taylor, who is looking at methyl jasmonate. Methyl jasmonate is a plant elicitor. It basically, if you spray methyl jasmonate, it induces a response by the plant. It just activating your immune system. And she have seen under lab, greenhouse, and even under field conditions that it reduces the damage of that pest. This is a relatively soft approach. Again, is somehow an early development right now. And then there is the RNAi pesticide. So that's very specific, very species specific. And we're working with a company that is called Greenlight Biosciences, who was the first one to develop an RNAi insecticide for Colorado potato beetle. We've been having conversations with them, looking at potentially exploring a treatment for sickle maggot, but you're looking at something that it won't be in place 10 years from now. So, and IPM alternative. So, non-treatment is an IPM alternative. So, we have data that probably 98% of the time you won't have an issue. So you don't need an insecticide seed treatment. And that includes non-neonicotinoid insecticide. That's another thing that we're educating the growers. Yes, we're facing away from neonics, but we're not moving into another pesticide. That defeats the purpose of what we're doing right now. So, and all the things that Dr. Poveda are looking at, all the cultural practices, agronomic practices. There's been in the literature, we thought that manure, cover cropping were increasing the pest abundance and therefore the damage on the crop. We're seeing that's not the case. And we're looking at some other things that can kind of provide some protection to the crop without any use of any insecticides.
Thank you. Go ahead.
At our field day, 3 weeks ago now, we had an etymologist speak, Dr. Thomas Dijkstra. He does a lot of work around Brix values and how high Brix values actually suppress insect feeding. And there was a question posed about, what about seedlings? And he said, well, it's actually at that point the level of micronutrients in the soil. If the seedling has access to the right micronutrients, the seedling's hard enough that those, biting insects and chewing insects can't actually, eat the seedling. And so sometimes it's actually looking at, do we have the right nutrition for that seedling? And that would be a simple seed coat, and some of those things. So there's a lot of different angles for attacking the problem. And humans just like to use the easy one instead of the one that requires a little bit more.
And I want to add a little bit to what Roy is saying. I think one very interesting fact we're finding about seed corn maggot is that they don't really like corn.
No, that's
Like
it.
they will completely finish their cycle on manure. They finish the cycle on residues of cover crops. So what we're looking at right now is, we started just looking at, if we have residues from cover crops in the soil, will the maggots completely develop their cycle and then do? And so right now we're just comparing like which cover crops could we use to basically lure the maggot away from the seed, because the window where the seed becomes attractive is like 24 hours. Where the seed opens, the maggots can enter, but one day later, the chemistry of the seed appears to be changing, and then it's not attractive to the maggots anymore. And so if we can provide something that is attractive during that time, that is something that's helping soil health, for example, like why not? Like, yes, it will require work, but it is at the same, like, I feel that the benefits are huge for everything. So we are looking into that more and understanding how cover crops, but also manure could be used. So what all the reports have shown before is like manure is attractive to the adults. And so people thought that because there's so many adults laying eggs on the field, once you manure, that means that the larvae are going to attack the crop, but it seems that the larvae are just eating the manure. So yes, we see an abundance of adults, but that does not translate into an abundance of damage. And yeah, we're trying to, like, a lot of what we're doing is basically understanding the biology of this pest, because it is not as simple as we thought, but it's also fascinating because it's eating everything else. Like, it's just eating residues of a lot of different things.
And just to add to what Dr. Poveda said is, well, I think we probably have to rename the pest. It's not really a corn pest. It's more probably even not even soybean. I mean, very limited situations. But what I tell the growers sometimes is this is a general insect. So it's not like the insect is waiting for you to plant the seeds and then start going, oh, there's the free buffet, corn and soybean seeds. Let's go after it. I think there is all that risk gets diluted under the ground. We don't understand what's happening. But that's also what we're telling the growers, we understand is when it happens, it can be bad, but it just happens less than 1% across the time. So is that the risk is still it's going to happen. We just don't know when and where it's going to happen. But what we've seen is that risk is very, very, very low.
Thank you. We probably have time for one more question if there's one more burning question out there. Great. I think we can wrap up then. Roy, Randall, Cory, Dr. Calixto, Dr. Poveda, thank you so much for taking the time to share your research and your thinking on this with us. It's so informative, and just the opportunity to hear directly from you is really impactful. So we've recorded this. We'll work on sharing the recording around with those who are interested. And if you have any questions, please get in touch with any of us. We're more than happy to talk through details, talk through questions that you didn't want to raise up in a group. I do this all day, every day, and I'm more than happy to find the right person if I'm not the right person. Thank you all for your time. Hope you have a good rest of the season, good rest of the summer, and we'll stay in touch. Have a good day, everyone.
Thank you, Allison. Bye.